So welcome to everybody, especially Happy New Year to our friends from China. We are now with the 7th webinar, and we have 3 topics which will be presented. And yeah, we start with the first one, which will be presented by John. Where is he? Here he is. Co-host. And now he is co-host again. So now he can take over. So John will tell us something about the reference programs and the calibration and what is new with the Mascata reference machine, the 6th edition.
Yes. Hello, everyone. So I think it will be fairly short because the reference machine by default is supposed to be static, and so it has been. Yeah, first of all, my name is John Johansson. I work at Electrolux Professional in our laundry division, where I am Energy and Safety Standardization Manager. I've been working with the reference machine for more than 10 years, and I'm active in several technical committees and working groups in IEC, also in some ISO committees that is touching textiles and washing. And I am the convener of the working group 19 for the reference machine. So the topics of today is the reference machine FOM71 CLS, the differences regarding the reference machine in IEC 6456, the differences between 5 and 6 edition, and the vital parameters for reference machines in terms of installations and ambient conditions and so on. And then we will talk a little bit about calibration and maintenance checks. So the reference machine that is available and is in line with the specification in the 6th edition is the Electrolux Professional Vascator FOM71 CLS. It's made especially for the purpose of being a reference machine, and it's been produced now for 22 years. And one big difference regarding the machine itself between the 5th and the 6th edition is that we no longer allow the former Type 2 machine that was on FOM71 MP Lab. It's allowed with 2 different machines in the edition 5, but in the edition 6 we decided not to go forward with this for several reasons. One is that it's more than 20 years since we stopped producing it at Electrolux, and hence there is no possibility to obtain spare parts or service or updated programs as such. And also it's not really relevant for modern laundry since it's a solid mount machine. The second thing we have changed in the standard to the 6th edition is that we have updated the cotton programs also to be a little bit more relevant for the time present. So we have increased the extraction speed to 1100 RPM. This will for sure lower the RMC values and give a little bit smoother process also, hopefully in the labs, not having to dry away all the moisture. And Annex F in edition 6 will give you the program definitions. So to the vital conditions. The reference machine shall be run under the same conditions as the test object, as stated in 5.1 in edition 6. And what we mean with that is that all the ambient conditions such as temperatures and voltages tolerances and water pressure tolerances and so on should be the same as for the test object. This is to be able to keep the accuracy and repeatability of the reference machine, because that is the point of it, to have a point to refer to when it comes to wash results. So as most of you probably know, we have the sinus circle is what is affected by, is what we call the four conditions or parameters that affect the wash result in any kind of cleaning. And we have the time, the temperature, the mechanical action, and the chemical composition of the that you use to clean something. And some of these are affected directly by the external conditions or ambient conditions of the reference machine, and mostly they are affecting the time. So what is very vital is the water pressure, the water temperature, the voltage, free drainways, and no objects placed on the machine. Now, if we look at the water pressure, first of all, it's regarding how quick the machine will fill the water into the drum. If you have a too low water pressure, you will have a longer filling time, which will give you a different wash result compared to another laboratory, which maybe have the nominal pressure or a high pressure. And a high pressure for sure will give you a shorter filling time. A too high pressure could also cause the machine to have inaccuracy when it fills the water. The water temperature, quite obviously, will also affect the time, because if you start off at a water temperature that is too high or too low, you will have either a too quick or a too slow main wash. Same goes for the voltage. There are different voltages for in all regions of the world, as you know, and hence also different voltage configurations for the reference machines sold in different regions. So what you should make sure is that your voltage level is in accordance with the heating elements that is installed in your machine, and those should be in accordance with what is written on the data plate on the back of the machine. Free drainways and not mechanically fixed piping. What do we mean with that? Free drainways, we mean that you should have a drain pipe which is not smaller than 50 millimeters in diameter. And this is to make sure that the machine can drain all the water necessary within the time stipulated by the controller in the machine. And not mechanically fixed piping, with that, the intention is to make sure that the weighing device used in the machine will work properly. And that is also the point of the last point, to not place any objects on the machine or lean anything against the machine. The weighing device in the machine is measuring the total weight of the machine and is tearing itself when you start a wash program, which means that it then can use the added weight from the water to see how much water it's filled. And this gives a very accurate filling. So if the pipe of the drain would be fixed, or any other pipe for that matter, or a strain cable or such, that would not allow the machine to move freely up and down. That would make the water filling inaccurate. So there is a rubber hose delivered with the machine, which is suggested to be used as the drainway or drain pipe. And preferably there should also be an air gap between the drain pipe delivered with the machine and any other pipe installation. So to the internal vital conditions that can be calibrated in this machine, we have the heating element resistant values. And the resistance of the element, of course, is giving you the power, the heating power of the machine together with the voltage. So there should be the correct voltage marking on the heating elements, and they should be within the resistance values given for that voltage. and the reason for having it as a calibration point is that resistance heating elements tend to change in resistance over time. So it's a good thing to control at least once a year. Weighing function should be calibrated. There is a fully detailed procedure for this in the user manual. And it should be made sure and preferably be traceable, of course, to a known weight. You should clean the inlet water filters. This is also, of course, depending on your installation in your laboratory, how often you need to do this, but at least once a year, preferably more often, to just make sure that you have no debris in the water filters and that you have a full flow. Otherwise, this will also affect the filling time of water. You should clean the drain valve. It's a known phenomenon that it ends up lint and other debris in the drain valve, even in a laboratory environment. You will have threads hanging from the heating elements down into the drain valve. And since the drain valve is a rubber baffle lifting itself towards the two surfaces meeting each other with an upward action. If you have too much debris hanging down there, you will not have a fully sealed drain when it's closed, which will make it leak, and you will have a different wash result to what is expected. You should also keep the heating elements cleaned. When you use a heater in a wash bath, there will accumulate limestone and other stuff. And when you have enough limestone on your heating elements, you will also have a slower heating of the water, which will affect the main wash duration. A good and easy way to keep the heating elements clean and to avoid limestone buildup is to use citric acid, about 0.5 kilo, and run the highest temperature program in your machine with citric acid to keep them clean, and do this on a regular basis. The bath temperature should be measured. It's a little bit trickier. Either you create a device to be hang on the door of the machine into the drum with a calibrated temperature device to see the temperature that you reach, or you can use, for instance, a data logger. You will have probably slightly different result if you use a temperature probe hanging on the door or if you use a data log. Probably not that much, but it's worth to consider. Normally, when we calibrate machines from the manufacturer, we use a probe hanging on the door. The water filling time, there is also instructions in the user manual how to check that, and it's time stipulated that should be between 2 points in the program. When you fill the water, that should be within margins to make sure that you have the right pressure and you have clean inlet filters and so on. The last chapter in the user manual is about calibration of the machine. The user manual is delivered with every machine, but if you do not have it, just contact me or your local service partner and you will have it. I will also share it to the round-robin laboratories in the common folder. That is all for me. Any questions?
John, thanks a lot. We would strongly recommend for all participants of this round-robin test to make a calibration of their reference machine shortly before they start with the round-robin test. We did not say that it is mandatory because we did not want to increase the burden, but we think it's worth to have it newly calibrated for this round robin test, because we're gathering a lot of data, and if they are wrong, because later we have doubts about the reference machine functioning correctly, then we will be angry with our decision not to make the calibration in advance.
Yes, that is very true. Thank you.
So, are there any questions to John?
Doesn't look like it. And if you come up with questions later or need advice for calibration, you are free to contact me afterwards. Thank you.
So, we go. Oh, okay. To Caroline.
Okay, yeah, hello to everybody. Share my screen. Good. So can you see it properly?
Yes.
Good, very good. So I will present you the new detergents, which are new in the 6th edition. Originally it was planned that Tatjana Friedrich from WFK and myself will do that together. Unfortunately, Tatjana is ill and not able to join. However, she's the expert on detergent. So if questions will come up which we need her, I think it's the best. I will share her email address in the chat later on, so she can be contacted directly. But maybe we can first try to answer it before we do that. Good, then I have divided this part of the webinar as follows. I will give you an overview first and then go into the single detergent and give you more details on the different detergents. And then the last point is weighing and dosing of the liquid detergents. Also related to the round robin tests, I will try to give you some information on the machines you use and how to dose it for your particular machine. Okay, then yeah, you see here the overview on the test material. Also the detergents are test materials in a broader sense, and they are described in Annex B and C of the 6th edition. IEC-P, so the standard powder detergent, P, and IEC-W, so the wool detergent, they are described in Annex B. Annex B is normative, and the 2 liquid detergents, so L1 and L2, are described in a separate annex, in Annex C. So this one is informative. And what does this mean? So when you have a look at the different performance parameters that can be measured, yeah, it's the following situation. So if you want to, for example, measure standard cleaning performance, and you want to have a valid test run according to the standard, then you have to use IEC-P, so the powder detergent P, to have a valid run. And also for cold water cleaning performance, you have to use IEC-P for a valid and according to the 6th edition normative measurement. For the wool cleaning performance and the wool shrinkage, you have to use IEC-W. So if you want to use the two liquid detergents, so IEC-L1 and IEC-L2, you can of course do that as an additional information for your internal tests, but the use of these two detergents does not lead to a valid test result. So this is important. The reason for that is that the two liquid detergents are relatively new developed, and we have only a limited database with these detergents. Anyway, it's good that a lot of labs try out those detergents, so we gain more experience and we learn more. And then in a later step, they can be maybe in the next edition, they can also be in the normative part as well. Good, then, so this was the introduction. Then I come to the different detergents. I will start with the standard powder detergent IEC-P and the changes from the 5th to the 6th edition. So the only change from the recipe of IEC-A star, so the one in the 5th edition, to the recipe of IEC-P in the 6th edition is the bleach component. So the bleach component was or is exchanged. So sodium perborate is exchanged with sodium percarbonate. So this has regulatory reasons. I will explain that later on. So this is one change. The other change is also the dosage. So the dosage in the 6th edition is lower and more consumer relevant than before. The dosage now in the 6th edition is the same as the one in the European norm, so it's corresponding to that one as well. Yes, furthermore, we have also lowered the dosage for the quality control of the stain strips in Annex A. This is an additional change. And this has some implications. The performance results, according to the 5th edition and 6th edition of IEC 60456, they are not comparable because we have A, a different bleaching component, and B, a lower dosage of the detergent. And then also the quality control data. So on these data sheets you get when you receive the standard stain strips, they will deliver different data for testing according to the 5th and the 6th edition. So this is also no more comparable. Good. Okay, so you see here the recipe of standard powder detergent P. As I said before, so the only change is the bleaching component, so the sodium percarbonate here. The base, so the rest of the detergent is the same. This is important for you to know. But because percarbonate has a higher active oxygen content, a lower amount of bleach is used in this detergent. So the composition of base, TiAD, and percarbonate, so this has a bit changed because of this higher active oxygen content of the new bleach component. Yes, furthermore, we have in this recipe in Annex B also changed a bit the way how it is reported or how it is written in this table. So product names have been replaced by the relevant ingredients. You see it, for example, here for the savinase, so the protease. Before it was savinase 8.0. Now we have here mentioned savinase X.0. So this does not mean that we have a different recipe now or a different protease. At the moment, it's still savinase 8.0, but it leaves some space open when the savinase 8 is no more available, and we need a newer one, which has the same reaction pattern and the same reaction sites. So it will lead to the same result, but it might be a newer type of the enzyme. Good. Then, so some words to this change from perborate to percarbonate. Yeah, the reason for that is that perborate will be prohibited in the European Union from May on this year. So in the European Union, it will be prohibited to ship, to store, and to use perborate from this date on, and therefore it has to be replaced. But as I said before, the base powder composition stays completely the same. You will also see that on the label of this base powder, we have changed that to IEC-A*/P base powder, just to make it clear that it is still the same product. Yes, it has some implications, it has some consequences. The replacement of perborate with percarbonate leads to different cleaning performance results because the solubility is a bit different of these two bleaching components. So the percarbonate reacts a bit faster and therefore also has a slightly different reaction pattern on the soils. So this makes some differences. It's not an issue for the 5th and the 6th edition because we also have a different dosage. So we will anyway have different results. But it also has consequences on the 5th edition. This one is still valid. For this detergent change, an amendment is published because it cannot be used anymore in Europe. In this amendment, it is described, so this replacement with IEC-P is described as well. But also here, the results of this 5th edition with IEC-A* and 5th edition with IEC-P leads to slightly different performance results. This amendment is available on the IEC web store for those that haven't seen it so far. I think for all labs outside the European Union, it's important to clarify if they still get perborate, so if they still can go on with IEC-A*, or if they have to change to IEC-P. Just make that clear for your lab and yeah, do what you have to do then if it's not available anymore for you. Good. Then the changed dosage. You see here on the left-hand side the dosing table for the 5th edition, and then on the right-hand side the dosing table for the 6th edition. And as you can see, for example, when we have a look at the reference machine with hard water, 40 degrees or 60 degrees, we have here 150 grams, whereas in the 6th edition we have, for the same condition, 103.4 grams. So it is really a decrease of the detergent amount. Good. Then I will go on with the wool detergent, so IEC-W. This one is new in the 6th edition. It has been developed over 10 years ago from several IEC members and companies. It was a joint work. Yeah, it is new in the 6th edition. Yes, I have explained that a bit more in details in the last webinar 6 about wool. So wool shrinkage was already described in the 5th edition. And in this procedure, IEC-A* was used to prepare the specimens, but also to perform the shrinkage test. So this is a change also for wool shrinkage. Now we use IEC-W, and for the new parameter wool performance as well, of course. As you can see in the composition of this detergent, it's a very simple detergent, a lot of enzymes and some preservatives, and that's it more or less. So it's good. Yes, this is again the dosage table for the 5th edition. As you can see here, we do not specify different detergents, so we just had an IEC-A* in that. And also for these wool tests, wool shrinkage, IEC-A* was used. Whereas in the 6th edition, the table 2 shows these 2 different detergents which are normative, so IEC-P and IEC-W, and specify the dosages of these different detergents for the different kind of tests. Okay, then I will come to the new liquid detergents. So standard liquid detergent IEC-L1, IEC-L2. So those 2 are, as I said before, specified in a separate annex. So the development was quite, was done in the last few years. So it's a relatively new work. As it was part of the questionnaire that such a liquid detergent should be developed and implemented into the 6th edition. So this was a task. We have now found 2 recipes that have fulfilled this task and can be used in the 6th edition. And as I said, it's still informative because we need more experience and more data with this kind of detergents. Yes, in the table you see the composition of the IEC-L1. So this one is provided by WFK. So we have given some requirements for the ones that have developed this detergent. So it's, for example, we have a relatively high amount of LAS that also rinsing efficiency can be measured in a washing cycle with this liquid detergent, and several other requirements that had to be fulfilled. So this means also that these liquid detergents L1 and L2, they have a certain performance, but they do not really represent real market detergents. This is anyhow relatively difficult because we have different markets and also different detergents on different markets. So it's yes, it's a good, I think it's a good solution, and it provides some certain performance. Yeah. Okay. Then also the recipe of the IEC-L2. So this one was developed by CSC from China. So the results of these two detergents are relatively close together, so they behave quite similar. And I think an advantage of these two is on one hand that it can be tried out, so we can try both out. Second point is that it's probably easier to get a detergent from WFK when you are located in Europe, or when you're located in Asia, it's easier to get it from China. So the shipment is easier. Good. Then the dosage. On the left-hand side, you see the detergent dosage table for IEC-P and IEC-W. So this is the normative part, whereas for the liquid detergents, the IEC-L1 and IEC-L2, the dosage is described in Annex C. And as you can see, the dosing or the amount is the same for the powder detergent and these L1 and L2s. Okay, then I come to the last point, so the weighing and mixing of liquid detergents. Because in the 5th edition we had only powder detergent, and therefore we need new descriptions and new procedures for these 3 liquid detergents in the 6th edition. The storage is for all liquid detergents the same, so for IEC-W, IEC-L1 and IEC-L2. So all these detergents can be stored at ambient conditions. You should store it in the dark, so put it in a shelf and not behind a window. Before you dose it, you should turn the flasks upside down twice, so to mix it a bit. And the accuracy of weighing should be 0.05 grams. For the reference machine, Electrolux Professional has developed a dosing device. And this one should be used for all the test runs with liquid detergents in the reference machine. So it's easy to apply. You can just place this device on the scale, tare it, and then add the liquid detergent directly to this dosing device. So this is easy and also allows the needed accuracy of weighing. See here more pictures of that. You put this dosing device in the main wash compartment. It's easy to insert it. You just have to take care that it's properly below this part of the detergent compartment. So there should not be a big gap here. Okay, yes, like I said that, you should put it in the main wash detergent compartment and then make sure that it's properly placed here without a gap. And then afterwards you can fix it or lock it with this part. So this one can be moved. So a little movie will show you the placement in the reference machine again. So as you have seen, it's easy to put it in the reference machine. Okay, then for the test machines, we are relatively happy in the round-robin test that for almost almost all test machines, we have a good solution, so we can take out a dosing device and place it on the scale, except for China, where this is not possible. There we have to weigh and dose the detergent via a beaker glass and a syringe. So this is the alternative when you cannot take out a detergent device or a detergent drawer directly and put it on the scale. Then use a beaker glass and a syringe. Place it on the scale and tare it. And then the syringe is filled with a higher amount or a greater quantity of the used detergent than specified. Just fill it up and then record the initial mass. And then you walk from the scale to the test machine and you add as long detergent as long as you have added the right amount. So you go to the machine, put in some detergent, then you go back to the scale and check if you have added enough. And if not, you go back to the test machine and you go on until you have done it. So we tried that out. I think also others did that. And I have to say it's a bit difficult to achieve the accuracy of 0.05 grams, especially when you use such a big syringe, as I see it on the picture, because it's difficult to control the addition of the detergent to the machine with such a big syringe. We have therefore also tried a slightly alternative method I would also like to share. It's still with the beaker glass, but we use the pipette. And what we have done here, we have filled the beaker glass with the detergent, also a bit more than you use for the test. We added the pipette on the top of the beaker glass and have tared the whole thing. And afterwards we have just filled the pipette and add the detergent to the test machine. We went back to the scale and weighed. So these two things together, the pipette and the beaker glass, until we see that we have added the needed amount to the test machine. So as you can see, in this case, we have added 70 grams. So this was a bit easier to do, so this worked better, but it was still a bit critical to reach the accuracy of 0.05. Yeah, so this is a bit an issue. I'm also, I hope to get some feedback, also, especially from China, which will have to use this method for the round-robin test. And yeah, I'm looking forward to hear more. So what kind of experiences have been made and how accurate this measurement was. Yes, and then another point is not only the weighing, we also have to apply the detergent to the machine. So this is relatively easy when a detergent dispenser is present in a test machine, and when this one is large enough, then it's just applied to this dispenser with the syringe, so for example, or with this pipette. When dispenser is not large enough, then it is filled up to the maximum level, and the rest of the detergent is placed in the drum, so in the base of the drum, before you load the machine. Then some vertical axis machine, the manufacturers recommend to use the detergent dispenser only with a delay start option. So in this case, the machine is just treated as if it has no detergent dispenser, and the whole amount of detergent is placed in the base of the drum. And yes, of course, when there is no detergent dispenser on a machine available, then the manufacturer's instructions have to be followed respectively. Also, the whole amount of detergent is placed in the base of the drum before the load is added. But fortunately, this is not an issue for the round-robin test, because all test machines, they have a detergent dispenser which is large enough to hold the detergent amount needed for the tests we have planned. Good, then I give you some practical information on the test machines you will use in the round-robin tests. So you see here the detergent drawer of the Miele machine. This is relevant for the round-robin test 6 and 7, so for wool shrinkage and wool performance. So Miele has provided a kind of dosage device which can be added to this main wash compartment. So you can put this into the detergent drawer. So in this part, take out take out the complete detergent drawer, then place it on the scale, add the detergent, and afterwards you just put the whole detergent drawer carefully into the machine and you can start your test run. So this is relatively easy, and I think also the accuracy of weighing should be achievable here. Then for the round-robin 10, we also have a good solution. So the detergent dispenser is removable. You can place it on the scale and dose the detergent. So inside this liquido compartment. So it's big enough or large enough to hold the amount of detergent needed. And then afterwards, you just put it back into the machine and you can start the test run. For Japan, so the round-robin 8, also a good solution is available. So the detergent drawer can be taken out and the detergent can be directly be placed into this detergent drawer on the scale, and afterwards you just put it back into the machine. Yeah, for China it's a bit more tricky. China has two machines, so a vertical axis machine with no removable dispenser, so it's an integrated dispenser. And here, yes, the solution with the beaker glass and the syringe or the pipette has to be used to weigh and dose the detergent. And then the horizontal axis machine, there is a detergent drawer available there, but as you can see, the detergent would run out if we put that on the scale and then place it there. So also here, yes, the labs have to use this solution with the syringe or the pipette and the beaker glass to weigh and to dose the detergent in the drawer. Yeah, I think that's it from my side. Are there any questions?
I have a question, Holy. When you have overdose the liquid detergent by preparing the dosing, so some milliliters too much, can you undo that in all cases? Or
No.
do you have to clean everything and start new?
Yeah. Yeah, I think that's a disadvantage of this method. Maybe I can go back. think this one, or also the other one, it does not really matter, it's the same. Yeah, what you have put inside your test machine is in the machine. So, yeah.
One question from Markus here. Why is it not possible to fill a syringe with the needed amount of liquid detergent and to have the same accuracy as you are dosing the full content of the syringe?
Yeah, I think the problem is that a bit of detergent is still in the syringe. So it's not.
But you can make a first dosing in a beaker glass, then the rest in the syringe. In the following dosings.
Yeah, I understand what you mean.
I think shall may be the same, but I don't have experience with it. With that, but
yeah,
that was my first imagination as I saw these pictures here or the description.
Yeah, we have tried that as well, and you have still you have still a difference. So between, but when you fill the syringe with detergent and then you remove it again or let it out and then you fill it again up and put it in the test machine, then there is still a difference of the amount. Yeah, of the third syringe filled up the first one, and then yeah, it's just not accurate enough.
Okay, it's bigger than this 0.05 grams.
Yeah, I think the best way is really with the pipette and well, a good device to how is it called? So when you see this one, so you can really do it very slowly, and yeah, because with this big syringe, it's also it's just very, very hard to fill it. And when you press it out, you cannot really control how much is going.
Yeah, sometimes it's not smooth. Then you dose more volume than you would like to do it. Yeah.
Yeah, there are also some automatic pipette things. I don't know how they are called. So you can. I think they have a battery, and so it's not this old one. So there are, I think, some other style of pipettes, but I really recommend all the labs that, especially in China, the ones that have to work with this method, just try it out first and find also the best solution for you.
And we are very interested to get your feedback.
Yeah.
Please, in all round robin tests, please practice one or more ways how to dose and report back what is good and what is not good. And if you have a better methodology, please report that back as well. Yeah, we are very open to learn how we can do it better.
Yeah.
Any more questions? If that's not the case, then I ask Caroline to put the email from Tanya in the chat. And thank you very much for this very good presentation. And I hand over to Markus.
So I share with you my presentation about the normalization. Pardon, Rainer?
We see.
What do you say?
We see your presentation.
Yeah, okay. Of course, I thought so.
I just wanted to confirm. Please go on.
Thank you. Yes. So my presentation is about normalization and conditioning methods, but before I like to to present myself. My name is Markus. I'm working for Miele here in Germany at the headquarters in Gütersloh for more than 30 years, and I'm active in the research and development department for washing machines and the washer dryers, and I'm working in standardization groups on different national levels. So my webinar, or my the part of the webinar, my presentation is about the normalization of base loads and the following conditions methods you can apply to this base load. For the normalization, there are some requirements. That means if you, or at first, the normalization has to be done to bring back the base load into an initial state, so that if you are running different test runs or different test series with this base load, that the results are not depending from each other. And for that, you have to ensure that the water quality used for this base, for the preparation of this base load for this test series, has to be the same as the parameters are for the test series itself. So you have to use the same water hardness for the normalization as for the following test runs or test series. The normalization has to be done by using a washing program in a reference machine, followed by drying in a tumble dryer. And this has to be applied for all base loads except for polyester base loads, as they are not normalized but only dried. The normalization intervals depend on the test class or test design you are using. So if you have an inter-run test design, that means that you have to normalize the load between each test run. That means you run a test run, you do the more normalization, you do the next test run, next normalization, and so on until the end of the test series. Or you have an inter-series test design. That means that you have no normalization in between the test runs. You run all necessary test runs, one after the others, and at the end, you do the normalization. That depends on the test class you have chosen for this test series. You can use different options of normalization programs. The first and well-known is the reference program in the reference machine. For this round-robin test, you have received or will receive with the test material these memory cards, smart memory cards or smart media cards. And on the first card for this round-robin test, it's the Cotton 60 program, which you have to use as a reference program. Or the next option is that you use a other washing machine, and I like to call it a reference replacement machine with a special replacement program, because it has to fulfill special requirements regarding the rinsing performance. So the LRS or alkalinity rinsing performance, depends on what you are testing in the test series, has to be on the same level as the reference machine, plus minus the given tolerance here. That means in advance, you have to run some test series in your lab where you compare this other this replacement machine in relation to the reference machine that it had the required rinsing performance. And you should set up a test report that you should set up and should have a test report about your results in the check of this special machine. And a third option in this round-robin test was created especially for this round-robin test. We have in the reference machine the so-called short normalization program. And here we have a small team from John Johansson, Rainer Stamminger, and me, where we tried to shorten the standard reference program to save time for those who have only the reference machine available for this test, and not to stress the reference machine so much. And with this with this short normalization program, you have a time saving of about 25 minutes. It's on the second memory card, and it's called option 6A-L RRT. And the difference between the standard reference program, which is called here in this table benchmark 1100, and this short normalization program, option 6A-L, is a time saving of around about 25 minutes, as said before, but the water volume is a little bit different too, because the reason for this is because it was changed from filling by weight to filling by level. But in our tests we have done here, we guarantee that the rinsing performance of this short normalization program is the same as in the reference program. For all who are running regularly these tests, a replacement machine is helpful, because then you don't stress the reference machine so much with all these normalization programs, where, as John explained, you have the threads, and the threads block the drain valve, or are laying on the heating elements and changing your behavior of the machine. So it is for the most labs, it's very common to use a replacement machine. Maybe you have two of them, so you are very you don't stress your reference machine so much, which has only to be run for the reference program for the washing performance or cleaning performance. Here you see the memory cards delivered by SwissAttest. On the left, there's a memory card for the standard reference programs. In the middle, that was the second card where a wrong program was on, so throw it away or destroy it, and afterwards you should have got, or you get it now, the third card, and it's called short normalization revision 2. This is the correct card, and here you see the program name is, as mentioned before, option 6A-L and RRT in the end. That's important. That's the correct one for the short normalization program. So any questions so far? If it's not the case, I will switch to the conditioning methods. So the conditioning has to be done after you have normalized the base load, and conditioning has to be done at the end of a test run or a test series, depending on the test class you have chosen. The drying of after the normalization before conditioning, this is a special drying. There you have to dry down to equal or below 0% RMC values for the baseload single items. Then you can condition your baseload. You have different options to condition your baseload. The first one is to use an ambient control room or chamber. This can be a climate chamber where you have the standard ambient condition. That means 20 degrees and Celsius and 65% relative humidity plus minus given tolerances. And that is what we normally call a climate chamber. Or you use the alternative conditions, and that is new in edition 6 in relation to edition 5. This was introduced. There you have the ambient conditions, what we normally have in the laboratory room, 23 degrees and 55% humidity, but these both must be controlled or regulated. That means you have to use a device which is regulating your humidity in the laboratory room, and that is not so common. But if you have such a laboratory room, you can use this alternative conditions, but at the end you have to be aware that you have to apply a correction factor, which is based on the load, not on the load, but on the textile type you are using. For cotton, it is this factor, but this is written in the standard. The procedure is to store the base load for not less than 15 hours in the room or chamber, whichever you use, and then you can take it out, and it's defined that this is then okay, or you use an alternative method there where you have to do 2 measurements at an interval of 2 hours and to note down the mass change and to see if this mass change is smaller than the given value of 0.5% here. But what is important is if you use a climate chamber or the laboratory room, that you log all the data at regular intervals so that you are sure that within this 15 hours or 2 hours, whatever you use, that the climate has not exceeded the given tolerances. So therefore, you have to apply a data logger system or something like that, which is controlling or which is measuring the ambient temperature and humidity in the chamber. Normally, you have a device which is controlling the climate, a big box which is attached to the climate chamber. There are temperature and humidity sensors inside. It is not recommended to use these devices or these sensors because they are normally hard to reach. And the question is, how can you calibrate these devices? Because the device you are using for measuring the temperature and the humidity here have to be calibrated regularly, so that it's guaranteed that your measurement data are okay. And beside these 2 options of using controlled rooms or chambers, you have a third option, that is a bone dry method, which is totally different, where you use a special tumble dryer with special specifications, higher specifications than the most household dryers have, so they don't fulfill this. Here you have to be sure that this tumble dryer you are using has or fulfills requirements, special requirements regarding the bone dry mass relation to the drum volume and the relation of bone dry mass to the heating power ratio. And further, it is important to have a manual or timer controlled dryer, so that the power input is not dropped down or cut by the dryer to by itself, because you only allowed to take out the textiles or the base load when the dryer is in the heating state. And to check this, it's easier to check this. It's helpful to attach an energy meter to the dryer. There you can see if the heating elements are powered on or off. You should preferably not split the base load into portions as long as the ratio mass here are fulfilled. So use the highest capacity, the highest allowed capacity for your tumble dryer. And at the end, you have to determine a bone dry factor for this special tumble dryer you are using. Yeah, any questions left? So if it's not the case, I hand over to Rainer.
Yeah. Sorry, I want to ask again if there are any questions. Doesn't seem to be the case. The message you should take with you is that we really try to provide you with options for doing this normalization. And the conditioning, so that you can be flexible in organizing your temperature. So you're here, it's not easy for me to speak. If there are no questions, then we close this meeting and we see each other again on Thursday.
Rainer, get healthy.
So yeah, I hope so.
Best wishes.
Bye bye.
Good recovery.
Bye.
Thank you.
Thank
Bye-bye.
you. Bye.
Thank you. Bye bye.
Thank you. Bye.